Hello and welcome. In this video I will explain how you can use a Raspberry Pi as an IoT device. My name is Magnus Eide. In this video I will mainly go over how you can use a Raspberry Pi as an input-output IoT device using Mongo DB and MQTT with Python. As a prerequisite, the Mongo DB server and the MQTT broker had to be set up in order for this code to work. This can be set up on another Raspberry Pi or server, but in this example it is running on the same Raspberry Pi. To visualize the data, I have created an HMI using HTML in a Flask application, but I will not go into more details about that in this video. Now I will go over the code for the IoT part of the Raspberry Pi. Before the main loop, the temperature filter is initialized and the sampling time is set to 10 seconds. In the while loop, the sensor gets the information of what kind of sensor is used, what the filter alpha value is, and what the alarm boundaries are. These values are retrieved from the MongoDB as they are rarely changed, and because MongoDB stores the values, they can be retrieved even after a reboot of the Raspberry Pi. The next thing it does is to read the temperature from the specified sensor. As of now, only two sensors has been configured, and that is the TMP36 using an analog to digital converter, in this case the MCP 3008, and the BMP280 that uses the I2C communication protocol to get the temperature data. Next, the temperature value is filtered using the filter class. This uses a discrete time low-pass filter, where alpha can be adjusted in the MongoDB. To disable the filter, the alpha value can be set to 1. The filtered temperature is then used to determine whether or not any alarms should be activated. The alarm boundaries can be adjusted through MongoDB, and two digital outputs are used to light two small LEDs to indicate high or low alarm. The updated alarm data is then stored away in MongoDB. The filtered temperature is then published to the temperature topic in the MQTT broker and saved to MongoDB with unit and timestamp. Finally, the temperature is saved to ThingSpeak for external use. Now I will show the system in action. Here we have the user interface, and as you can see, the temperature is updating every 10 seconds. If we go to the settings menu here, we have set the high alarm limit to 28 degrees and the low alarm limit to 20. The filter is disabled with the alpha value of 1. If we go back here, there's currently no alarm because the temperature is below 28 degrees. But if I take a lighter and heat up the temperature sensor, we should see an alarm in 2 seconds. Oh, that's not enough. There we go. And we have a high alarm. This is also indicated with a green light, as you can see. As the temperature goes below 28 degrees now, the alarm text will go back to no alarm. In the user interface, we can also have a look at the historical data. We can update it and see the peak we just created. This is unfiltered values, therefore the response is rather quick. Since all the clients except the ThingSpeak interface are on the same local network, the network security is at low risk in this implementation. The Mongo database and the MQTT broker are locally hosted, and the user interface is only available in the local network. To further strengthen the security in this implementation, a custom user in the Raspberry Pi has been added, as well as authentication in Mongo DB and MQTT. The web interface towards ThingSpeak uses the HTTPS standard and is therefore encrypted end-to-end. That's it from me. Thank you for watching.